Okay, good morning, everyone. Hello, I'm Alu. I'm here to have a talk about uh, how ISCN relies on IPFS. In the layman term, we are going to use IPFS to help us to distribute our decentralized content registry. Okay, let me introduce myself first. I'm Alu. Uh, I introduce myself with the hashtag developer, system architect, and new technology. Why I'm here is because I'm one of the promoters of the ISCN. What is ISCN? The full name of the ISCN is International Standard Content Number. Okay, what is it? You can have a analogy using the ISBN, but the ISBN is aimed for the digital content. So they are actually quite similar. The ISBN, I think most of you know that every book has a barcode at the back cover, and near the barcode, you may find the ISBN number. This ISBN number is unique to this book, and maybe you may not know that actually this ISBN number have some metadata in some database. If you can find that, you will know the just like the title, the description, who is the author, when and where this book propagate. So this ISBN actually is a unique ID as long as some metadata stick with it. So this ISBN is actually same, but it's aimed for the digital content. It is a unique ID for this for in the digital space. Of course, it have some metadata. So why we are going to promote the ISEN? Because we think that some of the use cases will be very useful for the digital content on the internet. One of those is the proof of existence. That means you may know that in the physical world, if you wrote a book, sometimes the author may post a set of draft to their own, so that this draft will go into the post office and will have a chop on them, and that chop will have a date on it, so that if one day they need to have a proof, they can show to other that, okay, on this day I post the draft to myself, so I'm the author of this book. This is the proof of existence. In the digital world, we also can do this proof of existence by the digital content registry, that is the ISCN. And the other use case is the profit sharing. You may know that some of the digital content production is very complicated. Let's say just like a music production, uh, so many people involved in them in the production, say the composer, the singer, the musician, and maybe a crew to make the MV. So many people involved in this production. Everyone is a stakeholder. So if we can record the ratio of the profit sharing between this stakeholder, we can programmatically process the profit sharing once there has some profit generated by this digital content. And the third use case is the license terms. I think most of you know that actually every digital content should have their own license term. Even the terms is no right reserved, or the terms is all right reserved, that means the copyrighted content, or maybe sometime it's the some right reserved, just like the Creative Commons. So if we have a digital content registry stick to the content, everyone can check this license term more easily. So you will know that, oh, can I use this content? Do I need to pay to the offer of the content? So I think if you uh, try to write blog, sometimes you may find the cover image. Every time I'm finding the cover image, I I'm happy to find the license of the image. Can I use it? Can I free to use it? Do I need to attribute to the user who is the author? Who is the author? So many questions, and every time it use so many time to find out the answer. So we define some grow, and we draft a ISCN specification. This is some grow of our specification, and what we want to do is actually is at least to work of this use case. So we need u- we need a unique global identifier. This ISCN metadata need to be traceable, and the schema must be extensible. And of course, these ISCN must contain the content fingerprint. That means the hash of the content itself, so that every unique ISCN number can relate it to a specific content. Every time you say, oh, this ISCN number, I know it is represent that specific digital content. And of course, this metadata need to trace the creation footprint. That means if I'm write an article or I write a blog, I use a cover image. Uh, this metadata should contain my metadata and also the cover image metadata, and also the license term informations and the stakeholders information, especially some hint about the profit sharing. But if we want to make such a registry for the digital content, actually it is hard to use the traditional technology. Why? Uh, we try to compare it with the blockchain technology. First question is, who create a registry? For the traditional database, you don't know. You can only trust the host of the database, who's he say, oh, he is the uploader. You must trust him, or say you cannot trust him. But anyway, you can only trust him. But in the blockchain, every transaction have a of the uploader shall know the owner of the hash string is the uploader. If one day someone can prove it, oh, I own this hash, that means he is the uploader at day one. The second question is when this record is created. It is very important if we want to do the proof of existence. Again, you can only trust the database host. You say, oh, this time is the creation time. Okay, you can only trust him. But in the blockchain, you can check the creation transaction. There has a timestamp, and this timestamp is you can trust it because of the nature of the blockchain. But now I'm not going to explain why. If you are interested, you can go to find some knowledge about the blockchain. What is the exactly content about the content registry? Okay, once again you can only trust the traditional database host, but you can examine it on the blockchain by the creation transaction. All data is logged in the transaction. You can examine them and try to find out, okay, is this really the metadata when it is uploaded? You cannot do it. And is it any modification in this time period? Once again, you only can trust the host. Do not cheat to you. They say this is the registry. Okay, you can only trust him. But if in the blockchain environment, the blockchain can control who has the permission to modify specific records. So everything is auditable. Everything you can check it by yourself on the blockchain. So use blockchain to implement an digital content registry is very important now you know. And we use our LikeCoin chain that is a Cosmos-based blockchain to implement this ISCN registry. Actually, this LikeCoin chain is a core framework for the LikeCoin ecosystem. If you want to know more about LikeCoin ecosystem, you can click this link. I will share this presentation later. And this LikeCoin chain is based on the Cosmos SDK. Uh, Again, you can check out the more information about this Cosmos SDK from this link. And the main usage of this LikeCoin chain is to process the reward transfer from the simulator in our creator fund pool. That means if some internet user or they are a simulator, if they click a LikeCoin button created by LikeCoin Foundation, this signal will be recorded. And if the audience is a simulator, the LikeCoin chain will give some cryptocurrency called like to the creator of the content that the user click the LikeCoin button. So the LikeCoin chain mainly to do this functionality, but now we add one more functionality to this LikeCoin chain is ISCN registry. What is the ISCN registry? It is an agent to help to store the ISCN metadata and to help the user to query this ISCN metadata. But if only use the blockchain technology, then we'll also have one big problem. It is about the distribution. As I said, as an ISCN registry, the ISCN registry need to fulfill two functionality. One is storing the metadata, and another one is help the user to queuing the metadata. So the blockchain is a very good technology to store the metadata because it is auditable, so everyone know that this metadata is trustable and no one can challenge it. But blockchain is not a good technology for the metadata distribution. If you want to queue in the data on the LikeCoin chain, you only can through the API gateway. But what if the API gateway go offline? Since this API gateway is hosted by some third party, so no one can guarantee this API gateway is the availability of this API gateway. Or more seriously, if some API gateway is banned by some of the authority, I don't know. It may be happen. I don't know. So the most most good way to ensure an API gateway availability is hosted by yourself. But from my point of view, even I am a technology guy, if you told me to set up an API gateway, I also think that it is a very complicated process to do so. So I don't think it is good for the layman user. So this is the advantage for of using blockchain technology for distributing the ISCN metadata. So we find that this technology is a perfect match for us to distribute the ISCN metadata. It is called the InterPlanetary file system, or you simply call it IPFS. Actually, it is a distributed file system. So many nodes host the content, and you can use a P2P client to connect to this network, and then you can find the data you want. So if so many people is distributing a specific content, you can find the specific content in no time. So it is a great technology for us to distributing the ISCN metadata. For the IPFS, actually it has few layers. The most lowest part is the network layer. Is done by the libp2p library, which is also created by IPFS team. It handle all the infrastructure, the network communication, how to route to specific content. So it is a powerful tool for a P2P network. And the middle layer is IPLD and IPNS. Actually, it is try to defining the data structure of the whole IPFS network. So it is a very core part for the whole IPFS system. And for the upper part is all the application that using this IPFS network. They use a IPFS client to connect to the IPFS network and go to try to curate some content from this network. And for our focusing point is the middle layer is the IPLD layer, this part. This part is called InterPlanetary linked data. It is a linked data structure by the name you can tell that. It is also a JSON-like data structure. It uses a CID content identifier as a addressable identifier. It is very important because this content identifier is like in this format, the base of the binary data version, the codec of the content type, and the multi-hash. Say this is an example of a CID. If I decode this CID, we get, okay, it is a base 32 string. So it is a CID version 1. The cooked type is has decimals 70. It is a DHE proto bus type. Most of the file on the IPFS network is this cryptid type. And the most important part is the hash. You can see that this hash is by SHA-256, and this is 32 by hash number. So every content have this hash and use this hash as CID. That means every time you query this CID, you can ensure that the content must be the content what you want. The integrity is correct, and no one can modify the data. Otherwise, you will fail to uh, retrieve this information. So it is very important. You don't need to worry about is this registry metadata is wrong, anything okay, so you don't need to worry about it. Okay, let's see some example of the real ISCN metadata. This is an example of the ISCN metadata. This metadata with this CID. So if record the ISCN number, this is the ISCN number. So if you tell others this ISCN number, they can query this set of uh, metadata at the creation timestamp, what is the version of this metadata, the intellectual property rights term information. What is this? I will demonstrate to you later in the demo. This stakeholder information, the content information, say the title, the description, any text about the content. So if we want to do such functionality, we need to implement the IPLD plugin. I don't go too deeply in how I go to make it. Otherwise, this talk will be very, very long. So I just pick some very important part. To make a IPLD plugin, you need to implement this plugin IPLD interface. Actually, this is a Go language. You need to implement this plugin IPLD interface from the IPFS core. And the most important interface is the register block decoder. And for the register input and code parser, actually we don't care about it because in our use case, we don't need to input or encode an ISCN metadata through the IPFS network. We only need to query the data from the IPFS network. So we only need to implement this one and leave this no operation is okay in our use case. So when we try to register the decoder, we implement this function, and this function will be called when the IPFS is start. So we tell the IPFS core that if you find this CID code that, please use this function to decode the binary data. So when decoding, it is just simply need to use this Zebra library. Actually, this Zebra library is made by IPFS Team 2 because this is a special Zebra library. For the common or general Zebra library, it is a JSON-like encoding method, but it don't guarantee the canonical because if you use a identical JSON to try to encode it, but in different order of the key value pair, the general Zebra library will give you different result. But in our case, this is not accept. So IPFS create a canonical Zebra library. That means even if you input different order of the keyword pair of same uh, keyword value object, they will give you same binary data. It is very important in our use case. Otherwise, uh, same data will have different CID come out. After that, after we decode from by the CBER library, we construct this object to a NOC object. This is the internal structure by the IPFS core. And after it, we can uh, try to stringify by the JSON encoding back by from this NOC information, and then we can serve the JSON like IPLD data to the client. I will show you that in the demo later. And the second part is the Datastore plugin. The IPLD plugin handled how we decode the data, and this Datastore plugin handled how we retrieve the binary data. Since all the binary data is stored in the LikeCoin train, so we need to implement this Datastore plugin to tell the IPFS core if we are trying to go to processing the IPFS, IP, ISCN metadata, please go to the LikeCoin chain to retrieve the binary data. Okay, you need to implement this plugin Datastore interface. And the whole concept is quite simply, you we only modify the internal plugin, the level DS, which is a level DB as a storage backend to store the IPFS data for the common IPFS daemon. We override 3 functions to achieve our goal. One is get, one is get size, and one is has. Just an example, the get. Uh, when a key is coming to this function, we check this key whether it's a ISCN type object. Okay, just decode the key and find out the type and check that whether this type is an ISCN object. If yes, then please call the Tenderman RPC endpoint to notify the LikeCoin chain and try to query the given CID to retrieve the raw binary data. After that, the IPFS core will pass this binary data to the IPLD plugin to try to decode the data. So let's have some demo. Okay, mm, I don't use time to download the IPFS. I assume you downloaded it. So now I try to run the IPFS daemon on my machine. Of course, this IPFS daemon is installed the IPLD plugin in it. So this IPFS client can handle the ISCN metadata. So first of all, I try to get this CID. Actually, this CID is the example in my presentation before. So after you query it, see, you can get it back from the from my local testing LikeCoin train. Okay, it get it from my local test string, so it get back the data. The ID is this one. Actually, it's exactly the one from my sample. You may find that some of the information is in this format. Actually, this is the function of the IPLD, and it is called Merkling. That's why I said IPFS is a perfect measure of use case. Uh, Let's see if I try to get actually. Actually, I use this CID to query the data. Okay, now I get the right information. Okay, the intellectual property rights term is here. Actually, it is a file I will show you later. And the holder is this one, and the type is a license. And why I say the Merkling is very powerful. Let's see. Uh, this command will query this ISCN metadata, and now I give it a path. See, now it is automatically go into this link, and it is decode it at the same time. So if I query this path, this CID with the path, I can directly query back the intellectual property rights information about this ISCN metadata. So I can also get back these terms, the legal terms about the this ISCN. Let's try it. Okay, this ISCN CID with rice. Inside the rice, please go into the rice. And since it is a array, so we pick up the zero index. And in the zero index, we're going to try to find the terms. Okay, let's start. Okay, it download a file. And let's take a look about the file. The name is same of the last portion of the path. Oh, great! It is a legal terms of the Creative Commons attribution share alike for 4.0. So this demo demonstrates to you that now if I try to find the data via the IPFS, I don't even need to know that there exists a LikeCoin string at the back end. I just simply get some data by this IPFS client. So this is what we have done on the LikeCoin string. We use this powerful IPFS technical stack to extend our LikeCoin string so then make it can distribute the ISCN metadata more easily for the layman user. And for the LikeCoin string itself, it is a creditable open database because everything you can audit by the block data, so you can trust that everything is correct, and you can find it on the LikeCoin string. And for the distribution part, we use IPFS. So just like the demo, the user even don't know, oh, there is a blockchain at the back end. So we use the advantage from the LikeCoin string, and at the same time use the advantage from the IPFS. So we combine these two, we perfectly to be an ISCN registry. Oh, this is what we have done. And if you find this thing is quite funny, actually you can do some contribution here. Okay, we have a GitHub repo called ISCN Spec. Actually, if you have some proposal, you can propose here. This is the last 5 proposal of the ISCN specification. And yes, this is some proposal. And if you have, if you want to contribute to this specification, you can go to this GitHub page and some reference link. And these two blog article, you can go to check it out because all of the content of this talk is coming from these two blog. So you can check it out by these two link. And oh, sorry, and the latest specification is right on this website, iscn.io. This is the most updated specification. What is our goal, our data model, exactly schema, some definition, Yes, so you can check it out here. And of course, if you want to know more about what LikeCoin is doing, you can check it out with this link. Okay, and so many links that you can check it out to know what we are going to do. And that's all of my presentation. So thank you, all of you. So any questions? So if no question, I think this is the end of the of my presentation, and thank you for our audience. Bye.